data and 4-point data. Another one is a 8-point data. So like that we can draw, and if it is a huge data point is available, now you can see rand in 1000 comma 1. The data will be generated 1000 data points randomly, and it will be equally divided into 25 bins. So now we can observe what is this plot indicate that whatever you are generating the data, 1000 data points, in that the range of the data points, you notice that in the you are dividing 25 bins, means total data is considered as a 25 partitions, and the nearest or what you call it as the range of the data point is given one bin, another bin, like that. We are trying to draw as the 25 bins. That will be as a this range of data will be more number of points are available. This is also little bit more, and some this range will be very less data points are available, like that. We can easily identify the data points from this. It is easy to understand the, suppose it is a class. Let us assume that in the x-axis maybe percentage if we take it 40 to 50, 50 to 60, like that. And by seeing this plot, we can easily identify which range of marks the students are having the highest number or highest count. This range of maybe 10 and this may be 20 or something like that. This may be 5. So in that manner, we can easily identify the range. So that's what we can do. Or in edges also, you can specify -10 to +10. If I specify, you can see -10 to +10, and then we can easily represent the rest of the data points, and which one will be as a more count, like that. And similar example, you can see here marks in a class without any roll number. Just I mention as a marks here. Suppose one student got 32, another student is 45, and so on. It is getting keep on, we can able to enter the data first. After entering the data, what we can able to do is we have to check the histogram. So in that point, you can see this is the marks, but in this marks, individual marks are, different kind of the marks are there, but I want to check how many students are having, let it be some 40 to 50 marks, or how many students are having some 60 to 70 or 20 to 30, something like that I want to check. Then you can create as a histogram. Suppose if I want to divide 5 parts, you can see here how many there is a following are the marks obtained out of 50 by 70 students. So these are the data. After that, the marks is given here. Now we can see if I draw the histogram, it is easy to understand by seeing the histogram. We can see this range 20 to 25 percentage of the marks is having very less count. Like that, we can easily observe the analysis, and this you can see this many count for something 40 to 50 or around in that range. So that is the way, and X label, Y label, title as usual, we can give it. This is the one chart, we call it as histogram. Another one is a pie chart. Pie chart is also a visualization effect will be more. So what we will draw is a plot. Data is given in a vector A. Let it be pi of A if we give. So suppose we can consider subject-wise marks. Let assume that, or maybe question-wise marks, or semester-wise percentage you want to see. If I plot a semester-wise percentage or CGPA, whatever you call it as, first sem, this is the percent, second sem, third sem, up to eighth sem, and make a pie chart. How the pie chart is going to be, which semester is having how much percentage, based on that, the in the pie chart, in the circle, it will allot the area. Suppose this is the thing. You are dividing this in terms of the data points, like that, which is having more content percentage, that will be allocated as a more area. Like that we can able to. Now we have to sum that area and divide it by that. Now we can see A 1, 2, 3, 4. In that 1, 2, 3, 4 is a points. Now I want to plot as a pie chart. Total how many? 1 plus 2 plus 3 plus 4. So let it be as a 10. Then 1 by 10, that much percentage for the A allocation and or means first point allocation, and 2 by 10, 3 by 10, 4 by 10, like that. We are dividing the portion and we can able to plot. This is one example how to plot as a pie chart. So what is the pie chart observation here? And the placement, let us assume that 2001 to 2006 placement data is available, and I want to plot a pie chart. In that, by seeing pie chart itself, we can easily observe in which year having more placement. In that case, we can easily identify. And bar chart also you can make it. I will show the pie chart as well. So bar chart, what we will do? X, this is 2001 to 2006. That means 2001 colon 2006, and P is equal to the data points we can give it, means the placement data, and bar y comma p, and x label y label you can give it. Even if you want title, you can place the title as well. And now by observing this bar chart, it is easy to understand, or cricket overwise runs, if you want to see that bar chart, it shows which year got the more placement. So like that, it is easy to analyze the data instead of giving numerical data like this. It is very pictorially, it is easy. That's what we can give it. And sometimes due to place constraint in a documentation, you want to represent in horizontal also, we can able to make it as a bar h y comma p, that will give you a view in the horizontal lines. It will be, that's for that you have to write here, instead of bar you can make it as a bar h. Now there is a style plot, same thing only, but different styles, nothing else. Same data, whatever we can observe here, 2001 to 2006, this is the data. For 2090, you draw a line here. And then 2002, we 120 data. You can write as a 120, but we have to connect this. This is what we call it as a Right. It is a nothing but a steps manner. That is one thing. Another one is a steel. So what it will do, this will be as a point, whatever the point, but it will be as a discrete manner. We can able to represent the data. So like that, a representation of the data will differ with respect to our requirement of our document. So that is the way we can able to represent. Now we can see same data or some other data you want to represent as a pie chart. So pie chart, what it is showing, 10, 20, 50, 10, 5. So in that case, we have to allocate the portion for the first value, second value, and so on. So what is the first value portion means 10 by sum of the total data, and 20 by sum, then 15 by sum, again 10 by sum, and 5 by sum. So like that, we can easily allocate the data point, and in that I want to make it as a legend also, because which color is related to what. So this is the first one, second one, and so on. We can able to represent 10 by sum will be this much percentage, then 20 by sum this much percentage, again 15 by 10, like that. We are keep on dividing the total circle in terms of the percentage based on the data, and we can represent. This is the pie chart. Similarly, I want to show in a one portion separately, or we can't highlight due to whatever may be the reason. If any case, suppose one semester you got more percentage, I want to show some highlight in that we can use it by using explode. This we call it as a one variable explode is there. So there you can give it as a zeros and ones. Zero means normal, and one if you make it wherever the one portion is there, that slice is going to be highlighted. So it will be as a explode from the circle. Now I mention here 2.1. I will show you here. There is a 0, 1. This 20 by some slice must be explored, and last 5 by some portion that will be explored. Now you can see the second one and then last one. This will be taken from the circle, or you can say that take it as a slice. So that is what we can use. Like that, if any point, not only two, if you want only one, or you want three or something, total data points may be anything. That is one thing. And another, you can see how to make a pie chart. Budget component in a house or in a month or something like that, expenditure. So what we required is components may be essential component, luxurious, entertainment or children education, like that. We have the different category. For that, how much you expend, expenditure is how much. You make a pie chart so that it is easy to understand which budget component or which header it will you allocated more amount or you spend more amount, like that. You can see for that we are given as a one thing is a X label amount or expenditure, and this labels you can specify whatever label it is there in the headers or components you spend in that, that you can give it, and explode wherever one is there, that alone will be take it as a out if I use that way. And now you can see this is the explode, a second one. Second one is a luxurious. So luxurious, I want to show, okay, this much amount I'm spending for this particular case. Similarly, if I don't want to make it this headers, or you can say that labels, directly if you make it as a pi of A, that will be dividing only the percentage, that percentage is going to be represented. So this is the way, lot of plots I explained simply for representation. Representation is used for the documentation classes, analysis purpose. Like that, many cases we are going to represent the plotting only instead of data points. Now again, 2D point, suppose you want to conduct one research or you are solving the problem with two methods, and then I want to compare the two methods results. So if I shown you, can suppose this is one method data, let it be this column, and there is another method data, this is a column. Names may be anything, whatever may be method name, we don't mind anything. In the any particular method, same problem may have the two different methods or three methods. You can solve that two methods for the particular problem. After that, how to analyze the two methods. The results more or less may be same, but many portions or many points we can observe from the what you call it as data. See, this many iteration, each iteration we have the data point cost function. Let us assume that this is also cost function, but make use of other method to solve the objective function. Like that, what I'm doing is, you know that CLC is clearing the window and clear all variables is going to be open. I mean, variables will be cleared, and then a test function is one name, file name of this data, and it is there in the Excel sheet, and I loaded it to one variable. Matrix name is the data is a one matrix. How many points in that? The matrix data, what is order now? Suppose if it is a 50 iterations, 50 versus uh, 2, 50 cross 2, because two rows, I mean 50 rows, two columns. So then I can make a data point is consisting of a 50 cross 2. And now I want to plot like that many columns you want, you can place it. I deleted some other columns as well. But if you want three methods want to compare or four methods want to compare, any methods you can able to compare. And A is equal to data colon comma 1. That means what is data name? It is a matrix name. Colon means all rows and comma 1 means first column. Means A, small a consisting of what now? Anybody can answer? Small a, variable name is A. If I type A and enter, what data A consists? The data A consisting this one, all the rows of this column, first column data completely is available in A. And similarly, B, that is equal to data colon comma 2, that will be represented. And now what will happen? You can see A variable consisting of first column data, B variable consisting of second column data, and so on. If you want many number of columns or many methods I want to compare, in that case we can able to store it into C, D, and so on. Now I want to plot this one plot and then second plot, two plots I'm plotting, and you can give X label, Y label, and so on. You can get the result will be like this. Now we can see if I give you only the matrix data point, you are unable to understand the logic behind in the data points with the numbers. But now by seeing this plot, what is observation is we can able to understand what is the first method result and second method results, what is the different and all. It is easy way. So one thing is we can observe which method is better by seeing the results. Anybody? By observing the data points, we can able to understand. Let in this case, second method is a better method. That is blue color line. The reason is our function is objective function is minimization. So what is happening? The cost minimization. We can see here. Now this cost is can see very less, and the red one is little bit more. So that is the one point you can say, because analysis I'm telling, even if the plot is ready, you have to write something analysis. So what is this analysis? It is start with first iteration value is very high, 825. Then gradually it is decreasing, finally reaches to lower value. It take 25 nearly 30 iterations. But whereas the second method, you can see it start with the initial value is 810, and it is dropping gradually by increasing the iterations, and it is you can see at the 20th iteration it is converged and it remains the value is same. So like that we can keep on analyze the data for analysis purpose. So this is the way we are able to plot the data. Now 3D plot. What is the 3D plot? Another parameter, XY is there, no? Normally 2D plot. So you'll get it as a Z also, another parameter. We can calculate each value of X and Y. What is the Z? And you can able to plot. For that, we have as a plot 3. There is one command is there. You can use it as a plot 3, X comma Y comma Z. You can easily plot the three-dimensional plot as well. For this, you can see I have as a x of t function and y of t function is there. You can make it as a x value and y value can calculate, and 2D plot you can plot normally, plot x comma y, it will give as a 2D plot. And if you want to plot another 3D plot, x comma y comma t, third parameter is a t in this case. Maybe some other case, maybe some other variable. Anyhow, we are able to do plotting for the three dimensional, or let it be as a three data points are there. Now, with respect to time, what is the value of x and what is the value of y, and you can able to plot. That will be, you can use the plot 3 command, you can able to plot. Now you can see this is the 2D plot. This is also 2D plot, different plots, and this one is a 3D plot. So x-axis is there, y-axis is there, and then time axis is there. Respectively, we are able to plot. So if you make it as a plot 3, x comma y comma t, that will give as a 3D plot. Another, you can see the there is a introduction of M files and all. So what we can do is there is a execution of sequence of commands in a normal line by line, some finding the solution to a particular problem. But what is the disadvantage in this is retype of same sequence of command in every time for solving as a similar problem. That's why what we'll do is, instead of writing the code repeatedly for the same sequence of steps, we'll go for as a another one file. Even later point, I will explain you the functions as well. Script file is usually the sequence of executable commands, and another form of the program is called as a functions. We'll go for as a function. Whatever function we are writing, that code is going to be, or you can say that the name of the function itself as a one of the parameter, or you can say that one keyword. If I simply type that keyword, the total program is going to be executed. So that is the advantage of a functions. That's why we have to go for as a functions as well. Instead of going for a script file alone, we'll go for as a functions. Now you can see how to create and save the run the file. This is the MATLAB window. If I click the MATLAB directly, it will be open, and you go for as a here new this one new window will be open. Already, if you have any program, I want to open
Excuse
it
me, sir.
and then run. Yeah,
Sir,
tell
sorry
me.
to disturb you, sir, but one of the participant had been joined starting only, but due to some connection and problems, she disconnected again. So can you allow her for a second?
Yeah, ask them to join now.
Yes, sir. Thank you, sir. Thank you very much. One second, sir. One second, sir. One second. Fatima, sir. Yeah. Thank you, sir.
Yeah. So now we can see there is a window will be open like this once if we click the MATLAB. In that, what we can do is, if you want to open one new window, and you can click here, and this empty window will be open like this. Our existing file you want to open and run once again, you just click the open and select that file, and it will be with code, it will be open. And whatever you want to write the program, you can write here, that automatically second line, third line, it will be display here directly. And then there is a run button. If you click this run button, automatically the program is going to be run. Or you select anywhere, and then you go for a step in run section, you can do that way also, and then go to step by step fashion, we can able to like that. If there is a alternate provisions are there to understand the code sequences and all. Now what we can do, directly can run the program by editor by clicking the run icon. As I said, by click the run icon, automatically it is going to be. If there is error, the line number, it will be display in the command window. You go to that line and rectify that error and runs once again, then it will be run. So that's what, if there is no error, what will happen? It will be run properly. If there is error, you have to debug that error and runs once again, and then only. And whatever file name is there, if you give it in command window, same file name, that program is going to be open. And by typing its file name in the command window, it will be considered as a total program is going to be executed. Underlining file name message appears, it means that file is not in the current directory. Suppose if you are in the C drive and your file is in the D drive, that will not recognize, then you have to change the directory while you are running the program one way, or other way what you have to do is you copy that file in from D drive to C drive and it will be run. So that is also another option. Now you can see there is a window is opened with existing script M file. Whatever file name, if suppose calculate the area is your file name. And edit, if you give the file name, automatically the program is going to be open directly instead of searching for path. If you know the file name, simply you type that file name and edit file name. If you directly type the file name, what will happen? It will run the program directly. That is what. Now we can see example. Create a MATLAB file called power.m using edit command. It can be saved in the current directory. However, the code will not work. What is the reason? The problem is if a file name is here is this one power.m. That's what I mentioned in even initial classes as well. The problem is here, all keywords, whatever the MATLAB keywords are there, if the existing keywords is used as a file name, then that will not work because the keyword is there for other purpose. Inside there is a subprogram. It will be there for the some specific objective. But now you are using as a file name itself as a keyword which is available in a MATLAB, then you will get the problem. That's what you don't use the power ABC or something SQRT. Some functions, inbuilt functions are available. No, that should not use. Now, anybody can solve this problem, or solve means it is only plotting I ask. So, what is the question? You can read all of you. Write the program to generate at least 2 cycles of 3-phase 50 Hz 230 volts line to neutral and line to line sinusoidal voltage waveform you have to draw. For that, what is the requirement? They have given Vmax this one 230, and you know what is the AB or ABC notation or RYB notation, anything you can use it. Suppose phase voltages, three-phase supply. What is the phase voltages? There is a VAN, VBN, VCN. That is the phase voltages. VAN is Vm sin omega t. VBN, that is nothing but a Vm sin omega t minus 120, and VCN Vm sin omega t plus 120. So like that, this is known to you. And only calculation is what? Vm. So what is Vm? We are root 2 into VAN. So that you can write it. And once if you know the phase voltage data, and what we required is a line voltage. How will you get the line voltage? Directly VAB is nothing but VA minus VB, and VBC is nothing but VB minus VC. Like that, you can simply subtract that. That data also available now. Once if you, what is the T here? You make a T 0 colon some increment colon up to 2 cycles. Therefore, it is a point not 2. Or you want to make it point not 8 or any value, that many number of cycles is going to be displayed. In that, while you are writing the program, what is required? First, you have to define T, and then we'll go for omega t, then Vm, that is a root 2 into Vs. If that data is available, straight away we can find Van is equal to Vm into sine omega t, and Vbn and Vcn. Like that, we can able to represent An, Bn, Cn notation. We can make it. So now you can see the program. Base voltages you define 230, and then frequency is 50 Hz. Vm is SQRT, that means root 2 into phase voltage, and omega is 2 pi f, that is the basic data. Now you require this data, store it into one data file for writing purpose. This is provision is available in MATLAB. You can able to open one file name for writing purpose, or existing file you can able to open for reading purpose, or existing file you can append some data. In that case also we can use the A instead of W. You can use A. You can able to append the data into existing file and so on. Like that we are opening, and for that F open as ID is given. Now the file consisting of this ID, FID something. And what I want is, I want each value of x. What is x is t. For each value of x, I want to calculate the VAN, then VBN, VCN, and so on. We can able to calculate the or draw the three supplies with phase shift of 120 degrees. For that, I taken as a t from 0 to 0.04, and then we have to uh, calculate what is the A phase voltage, B phase voltage, and C phase voltage by giving VAN is equal to Vm sin omega t, VBM is equal to Vm sin omega t minus 120 degrees. That is the reason 2 pi by 3 I made it, and VCN is equal to sin omega t plus 120 degrees. So therefore, we'll get it as a AN, BN, and CN. We will get all the three. After that, line voltages VAB, BC, CA straight away by subtracting A value means VA value minus VB value, like that we'll get it as a VAB, and all others also. Now we got the, here we'll calculate the phase voltages. Here we can calculate the line voltages. Then you can save the data into one matrix or with the name of Y or something, any variable you can give it. And print the data also is possible. And because we have opened one file with Excel file to store this data, and also we have to close that also is required. Once the file is open, properly we have to close. How syntax we are using for file open. Similar fashion, closing also, or many number of files are there, we can easily close that. And then we go for as X label, Y label, title, all these things you can give it, and you can see program legend, all if we provide. Then what is happening? Simply we can able to draw three-phase supply with AN, BN, CN. That is a first one is a phase voltages, second one is a line voltages. So AN value, BN value, CN value, that represents the line voltages. So we can easily draw the plots using the plot command, or two-dimensional or three-dimensional, or whatever description is available in the departments. That data we can able to plot in other manner also, not only for this problem. Pie chart or bar chart or histogram manner, like that many cases you can able to do. And we'll go for as a functions, as I mentioned in previous topic. A script have one main disadvantage, that they cannot have the input and output variable. Simply you have to define the variable and you will solve that problem. But whereas the directly to assign the variables is not possible. But MATLAB is another type of more generalized called as a functions. We have as a functions. Using the function, it will be standalone program, can be used in any program, in the script or in the another function. So like that. In this, we can see the function can have input and output argument. Then function definition line. One, because how to write a function, we are dividing as three parts. One is function definition line, another one is h1, and then the help text line, and then function body. In that case, so suppose how this first line will represent, then help line will represent, and body will be, I will show you this. The function syntax will be like this. Anything, not only the this alone. Function is a keyword you have to start, and this we call it as output variable. and this is a function name, and this one we call it as a input variable. So like that, we have to divide the function into three parts. So one is a function definitional line. This first line we call it as a function definition line, or this line itself I call it as a function definition line. How to represent function definition line? Function output variable that is equal to input function into input variables. So, or within a bracket, or you have to pass argument that is input of data, and it will return the output by executing the function. Therefore, here itself, or from other program may get the data to execute this. This is also is possible in this case. Now, a small program, what is happening? The function, this is the line, first line will represent function definition line. That's what you can see. Function is a keyword. There is a function output variable is this one, and then function name, or you can say that input is this one, and then mm, this is the input, and this is a function name here. This is a function name, this one is a output name. So like that we will get. And we can see the problem from here onwards, it is easy. Only thing is, I shown you the small problem, small problem. But whereas if we go for any big project and all, we must write the assignment to execute the program properly. Now here, what is the our main function is x is given 1 to 10, means x value is 1, 2, 3, 4, 5, and so on up to 10. And y value, I want to calculate x, each x value, what is the y? Suppose x is equal to 1. Then SQRT of 1 here. What is SQRT is our program. This is what the function problem. And similarly, there is a 2. In that, what you have to use the calculation? 2 we got it, SQRT of 2, square root of 2. So like that, uh, there is a values you can see 5. So not square root. This function name is XSQ, not SQRT. It is XSQ is a function name. You have to write the function. What you have to do? Anything you can write there in the equation. These values will go there automatically, and they execute that and return that variable. Here is the output. So like that, we can pass. Now, what is doing in this function? Whatever the value function is output, and input you have to pass. The input is 1, 2, 3, and so on up to 10. This is the input. And then what is happening? Input square is your output. Now input we are getting as a here 1. So 1 square output will be, again it will return here, output will be y. And again second value it will go as a input, that is a 2. 2 square, that will return to 4. Then input will go to 3. Then 3 square, it will be 9, and so on. Then this is 4, and return the value is a 16, and so on. So this is the way we are able to represent your nowadays plots. These are all by make use of what you call it as functions. Now, other one you can see the same main program, let it be 1 to 10. I want to do two things. One I have to do squaring, another one I have to do cubing. In that, 1 to 10 is your input, and then your function name. This is main program. 1 to 10 is your uh, normal values. In that, I want to return what is square of that x value and what is the cube of x value. For that, I wrote one function separately. The function name is x powers. This name must be very important. This name must be same as the file name. This name must be given as a function name. That is the case. Now, first value, what it will be? X is equal to 1. Now, if x is 1, where it will go? You can see the sequence of execution, x is 1. So here x is 1, it will go to function within a bracket 1. So x powers 1, it will go to this x powers, and here it will be 1, and then 1 square, 1 cube. What is that? S cube is 1, cube value is 1, that return again here. Like that, you keep on doing this. X is 2, and this will go to here input of 2, and it will return SQ and then cube. Like that, we can able to represent your data in the programming part, main program as well as the sub program. In a sub program, again you can write nested functions as well within a sub program also. Like that, I have given some more problems here. Main program is some data is given x1, x2, x3, and multiple of x1, x2, x3 is the inputs, and we have to calculate the y1 and the y2, and here they mention the y1 equation and then y2 equation. So like that, and more functions. This is about total MATLAB programming part. Now, what we have to do is in the next topic, we'll go for as module 3 is a machine learning module. Module 3 or 4, I think. So, in the machine learning, we'll start. After machine learning, what we'll do is we'll go for as another unit, that is the last unit. By make use of this thing, what you call it as MATLAB programming, we have to solve the problems. What are the problems? Whether it is a series operation problem, parallel operation problem, or mesh analysis, nodal analysis. Another one is superposition theorem, maximum power transfer. Like that, how we are able to solve using programming part. The same MATLAB program we have to use to solve the application. There our application is what? Suppose circuit they may give verify the superposition theorem. You have to write a program to verify the superposition theorem. Similarly, other thing. So like that we need to do. I will start. Shall I start the machine learning today? Anybody?
So you can start in the next class, sir.
Yeah, here we have only two more modules. One is machine learning, one module. Other module is networks. So the network problems we have to. So I think tomorrow I will have one more class. I will start the machine learning by tomorrow. Okay.
Okay, sir. Just can you share with the notes like for the reference purpose?
Yeah, I will share it. So after completion of this, I will share the total material to all of you in the mail or maybe in group is there. That I will share it. No issue. Anything?
Thank you, sir.
Okay. I will end the meeting.